Alright guys, today we're going to learn how to change forms. So we're going to go from standard form to vertex form, and we're going to be using completing the square. So part of the success criteria that you need to know is you want to, number one, make sure that your equations are in standard form. And secondly, we want to move the constant to the side with the y. So please pause the video. Please write down these first two steps, and then we will continue with this procedure. Okay, welcome back. So first thing we want to do is we'll make sure we're in standard form. So remember, standard form looks like this. Okay, so we're going to do a little bit of rearranging here, and we want y to be positive, so keep that in mind. Okay, when we're doing this, we want y to be positive. So since y is positive here, I'm just going to go ahead and move all of this stuff over here. So I'm going to cancel out the 10. Okay, these are not like terms, so we cannot combine them. Cancel out the minus x squared. Again, these are not like terms, so we cannot combine them. Okay, so what I'm going to do now is I'm going to go ahead and order this, starting with the highest exponent. So we're going to have x squared, then the 8x, and then the constant equals y. So now we're in standard form. It doesn't matter if the y is on the right or on the left. It doesn't matter. We're still in standard form. Success criteria number 2, we're going to go ahead and move the constant back over here. And I just want to do that. I know it was over here, but it's not always going to be on the side with the y. So I want to make sure you guys understand. So we're going to go ahead and move the constant over here with the y. So we're going to move it back over like that. So we're going to have x squared plus 8x, and we're going to find a new c value here. We're going to find a new value because we want to make a perfect square right here. So to get a perfect square, remember that a perfect square, some examples of perfect squares. So if I square 1, 1 is a perfect square. If I square 2, 4 is a perfect square. So anytime we multiply some number times itself, we get a perfect square. So here, what we're looking for is we're looking for some quantity squared. Because that's what we're doing to get a perfect square. We're taking some quantity, in this case it's just a number, and we're squaring it. And when we square it, we get a perfect square. So we're going to try to make a perfect square right here. So in order to do that, success criteria number 3, we're going to take half of the b value, and then we're going to square it. And that's going to give us our new c value right here. So let's go ahead and do that. So we're going to take half of 8, and we're going to square it. So that's going to give us 4. 4 squared is 16. All right. So our new c value is 16. Now, since we added 16 over here on the left, we have to add 16 on the right because it's an equation. We made a perfect square here. You might be thinking, well, Mr. Kramer, how's that a perfect square? I thought you just said that it's some quantity squared. Well, that's a good question. I'm glad that you asked it, Travis. We're going to rewrite this in this format. Okay, so success criteria number 4, we're going to rewrite this portion right here into this format. This may look familiar because it's vertex form, right? Remember, the goal here is to go from standard to vertex form. So to get this into this format, we start by bringing down the parentheses in the square, and we're going to bring down just the x, and we take half of 8, half of the b value. So to get h right here, we're going to take half of b in order to get h. So half of 8 is 4. Now you may be asking yourself, well, wait, it was this and now it's this. Well, if we square x plus 4, we're going to have x plus 4 times x plus 4. And if you'll remember from Algebra 1, to multiply this, we distribute or FOIL. So we multiply x times x, x times 4. And then we do the inner, that's the first terms, then the outer terms. Then we do the inner terms. And then we do the last terms. So we end up with x squared plus 8x plus 16. See? Same thing. This is a perfect square. Why is this a perfect square? Because x plus 4 times x plus 4 is this. Alright. So we get y, 10 and 16 is 26. And almost done. We need to move that 26 over here. So we're going to have x plus 4 squared minus, because we're going to subtract 26, minus 26 equals y. And now we are in vertex form, with our vertex being -4, -26. So this is the procedure that we follow when the a value is a 1. Now what happens if our a value is not a 1? Say a -2 or a 4? Good question. Well, let's take a look at an example, shall we? Okay, so looking at this example, again, remember our success criteria, we wanted to put in standard form. So we're going to have this. Okay, success criteria number 2, we're going to move that constant over to the other side. So we're going to get this. So far so good, right? So now, notice our a value is not 1. So we're going to have to do something a little bit different here, an additional step. So when a does not equal 1, you need to factor it out. Okay? So we're going to factor the 2 out. So factoring a 2 out, remember factoring means divide. So let's divide. So 2 divided by 2. Now we got a 1. See? 1x squared. Okay? Negative 6 divided by 2. Negative 3. And we don't know what this number is yet, so we're just going to put a blank here. And we're going to assume that we factored it out of that number. Okay? All right. Now, we're going to go back to what we know. So the a value is now 2. And we're going to change forms. So we're going to take half of b and square it. So we're going to bring down the x. Half of negative 3 is negative 1.5. And I'm going to go ahead and square it, because when you take half of b, you put it here. But when you square it, that's going to go here in for our new c spot. So what's inside here, remember, is what goes in here. But when you square it, that's your new c. Okay? So squaring this, that's going to be 9 over 4. So plus 9/4. Negative 3 times negative 3. 2 times 2. All right. So here comes kind of a tricky part here. Is we did something over here. Remember, if you do something over here, you got to do the same thing over here. So pay close attention. Wake up. Take a drink of that Mountain Dew right now, because you need to follow along. So on the previous problem, if we added 9/4 here, we added 9/4 here. But remember, we factored out a 2. So the real number that we added over here is times 2. So you actually have to multiply that 2 times that. 2 times 9/4 is 18/4. That's the actual number that we added on the left side. So that means we're going to have to add 18/4 to the right side. Okay, let's do a little addition here. So we got negative 7 over 1 plus 18 over 4. Getting a common denominator. So 4 and 4. So if I multiply the bottom by 4, I have to multiply the top by 4. I get negative 28. So that's going to give me negative 10/4, which is negative 5/2, or if you will, negative 2.5. So we get y minus 2.5 and adding the 2.5 to bring it over here to this side. So we have our a value, we have our h value, translated 1.5 units to the right, and we now have our k value, translated 2.5 units up. All right, so look this over, try to follow the steps that I took, and let's come to class ready to ask questions, practice, and remember, this is the most difficult, transforming from one form to another. The rest of them are pretty simple. See you tomorrow.